Okay, so if I put you in charge of building a new AI system today, say one that decides who gets a mortgage or who gets an interview for a top job, and I told you, look, above all else, this system has to be fair. What's your first instinct? I'm willing to bet money. Your first move is to open up that spreadsheet and just delete the columns for race, gender, religion.
It's the most natural thing in the world to do. You think, well, if the computer can't see that I'm a woman or that I'm black, how can it possibly discriminate against me? This is, it feels clean. It feels logical.
Exactly. It feels like you're taking the ethical high ground. But here's the thing that, honestly, it blew my mind prepping for this.
Yeah.
That instinct. It's wrong. In fact, it might be the most dangerous thing you can do.
It sounds completely backwards, doesn't it? But yes, that approach, what we in the industry call fairness through unawareness, is, well, it's essentially a trap. And the paper we're looking at today, one by Ize from last year, 2025, argues that by deleting that data, you aren't stopping bias. You're just blinding yourself to it. You're giving it a place to hide where you can't measure it, and you certainly can't fix it.
Which is a terrifying thought.
Yeah.
I mean, we've been told for decades that color blindness is the goal. And now it turns out that in the world of algorithms, being colorblind might just mean you're flying blind. So today's deep dive is all about navigating this complete mess. We're looking at the paper including or excluding protected attributes in AI models, and the mission really is to solve a paradox that I think every single company is struggling with right now.
Oh, it really is. It's the central headache of modern AI development.
Right, because on one side, you have all the privacy laws.
Right.
GDPR, the new Data Use and Access Act, and they're all screaming, minimize data, don't collect the sensitive stuff, keep it private. And then on the other side, you've got the fairness saws and the ethics board screaming, prove to us that your AI isn't racist or sexist.
And you're just stuck in the middle. You're asking, how can I possibly prove the system isn't racist if I'm not allowed to know the race of the people it's judging?
Exactly. It's a total catch-22.
Yeah.
So we're going to unpack that paradox. We're going to look at some absolute disasters like the Apple Card mess, the UK A-level scandal, see what happens when you get this wrong. And most importantly, we're going to walk through a framework from the paper called PAUDF. It's basically a playbook for how to handle this, like radioactive data, without getting sued or completely destroying your reputation.
And that framework is so crucial because it moves us away from just, guessing and gives us an actual strategy.
Before we get to this solution, though, we have to really understand the trap. Why doesn't deleting the gender column work? I mean, if I'm a bank and my AI model literally has no idea if an applicant is male or female, how could it possibly be sexist?
So to get that, you have to shift how you think about AI. We tend to anthropomorphize it. We think it processes information like a human. But an AI model, it's really just a pattern matching machine. It's a detective that is relentlessly, single-mindedly obsessed with maximizing accuracy. It wants to predict the outcome, and it will use any scrap of data it can find to do that.
So it's looking for shortcuts.
Precisely. If you take away the explicit label, say gender, the model doesn't just throw up its hands and say, oh, I guess I have to be neutral now. No, it goes hunting. It looks for other data points that correlate with dister to use as a substitute. We call these proxies.
Proxies. Okay, let's drill into that. What does a proxy look like in the real world?
The most famous one is probably the zip code or postcode. In many countries, the US and the UK included, neighborhoods are still effectively segregated by ethnicity or socioeconomic status, due to historical housing policies.
Right. Redlining, gentrification. Geography tells a story.
It tells a huge story. So you delete the race column, the model starts looking around, and it notices, hey, wait a minute. People in zip code A tend to default on their loans more than people in zip code B. So it just starts downgrading everyone in zip code A.
But because zip code A is, say, predominantly black or Hispanic, the model has effectively just reinvented redlining all by itself.
Yes. It's discriminating based on race, but it's using the street address as a kind of loophole. And the developers, they might look at the code and say, look, no race variable, we're compliant, all while the output is completely biased.
And the paper mentions some that are even sneakier, like hours worked.
That's a big one for gender. I mean, statistically, in many societies, women are more likely to work part-time or have gaps in their employment history, often due to childcare or elder care responsibilities. So if an AI model decides that gaps in employment or part-time work makes you a risky borrower or a bad job candidate, it is indirectly penalizing women.
And the model doesn't know it's being sexist. It just thinks it found a really clever correlation between hours worked and, say, job performance.
Exactly. It thinks it's being smart. It doesn't know context. It has no idea about sociology. It just knows math. And this is the ostrich effect that the paper warns about.
The ostrich effect.
Sticking your head in the sand. If developers delete the sensitive data, they feel safe. They feel like they've done their moral duty. But because they deleted the data, they can no longer check if the model is using these proxies. They can't run a test to see, hey, are we rejecting more women than men? Because they don't know who the women are anymore.
So fairness through unawareness is really just fairness through ignorance.
That's a perfect way to put it.
And this isn't theoretical. We've seen this blow up in real life. The Apple Card thing was a huge news story a few years back.
Oh, it was a watershed moment for the industry. You had a situation with very high-profile people, tech executives, Steve Wozniak even. Husbands and wives were applying. They filed taxes jointly. They shared all their assets. And in some cases, the wives actually had better credit scores.
But the husbands were getting these massive credit limits, and the wives were getting, peanuts.
Or just getting rejected entirely. And, naturally, people called it out as sexism. Apple and Goldman Sachs, who is the bank, they immediately came out and said, that's impossible. We are blind to gender. The algorithm doesn't even have an input for male or female.
They really thought that was the defense.
They did. They genuinely believed that because the input wasn't there, the bias couldn't be there. But the model was almost certainly latching onto proxies. Maybe it was spending patterns, shopping at certain types of stores, or buying products that correlate with gender. Maybe it was how co-ownership of assets was structured.
And because they were blind, they didn't catch it until it was a PR disaster all over Twitter.
Right. If they had collected gender data and just tested the model before launching, they would have seen, whoa, hold on, why are women getting 40% lower limits? And they could have fixed it, but they didn't look, so they didn't see.
Another one the paper gets into is the UK A-level scandal in 2020. I remember this one so vividly because it wasn't just about money, it was about kids' futures.
That was a textbook example of how proxies can enforce class structures. Because of the pandemic, exams were canceled, so the government used an algorithm to assign grades for university applications. They couldn't use individual performance data from that year, obviously, so they used the historical performance of the school as a key variable.
Which sounds neutral on the surface. Is this a good school or a struggling school?
But school performance is a massive proxy for wealth and class. Students at expensive private schools, which, historically get high grades, they got their predicted grades boosted by the algorithm. Meanwhile, students at state schools in poorer areas, even straight-A students, got downgraded because the algorithm just decided, well, kids from this school usually don't do this well.
That is just heartbreaking. It essentially told those kids, you can't be smart because you're poor.
It automated inequality. And again, the algorithm wasn't trying to be classist. It was just optimizing for a pattern. But the result was that thousands of students lost their university spots until the public outcry forced the government to scrap the whole system.
And then there's the Dutch child care benefits scandal. That one feels the heaviest to me.
It's the darkest example. This wasn't just about grades or credit limits. This was the government accusing its own citizens of fraud. The Dutch tax authority used an algorithm to flag families they suspected of cheating the child care benefit system.
And what was the proxy there?
Dual nationality. If you had a dual nationality, the system flagged you as high risk.
Wow, that's barely even a proxy. That's just profiling.
It combined that with zip codes, other demographic data, and the result was that thousands of families, mostly from migrant backgrounds, were wrongly accused. They were forced to pay back tens of thousands of euros. It bankrupted people. It broke up marriages. It was a human rights disaster.
And again, it just highlights that data minimization, just keeping the data set small to protect privacy. It doesn't protect people if the remaining data is just loaded with bias.
Exactly. And this brings us right to that governance paradox we mentioned at the top. This is where the legal teams usually start fighting with the data science teams.
Right, because the company lawyers are looking at GDPR or the new Data Use and Access Act, and they see race, religion, health, political beliefs, all listed as special category data.
Which basically means toxic waste. You need a very, very strong legal justification to even touch that data. So the safest legal advice is usually don't collect it. If you don't have it, you can't leak it.
But then the compliance officer walks in, holding the EU AI Act, and says, we need to certify this model is fair. Show me the proof.
And you can't prove fairness regarding race if you deleted all the race data. That is the measurement paradox the paper illustrates so well. You are legally required to be fair, but legally discouraged from collecting the data you need to measure fairness.
No. Are we just stuck? Is there a way out of this?
This is where Eze's paper becomes really valuable. The core argument is we have to start treating this as a binary switch. It's not just include or exclude,
Mhm.
it's a governance decision. And the paper proposes the PAUDF, the Protected Attribute Use Decision Framework.
PAUDF. Okay, doesn't exactly roll off the tongue, but let's break it down. It's basically a menu of 4 options, right? 4 modes a company can choose from.
Exactly. Just think of it as a spectrum of risk and utility.
Let's start with mode A. This is
Sure.
explain.
Mode A is the status quo. You do not collect the protected attribute, or if you do, you scrub it immediately before it touches anything.
Which, as we've established, is the danger zone for fairness.
Right. It's got the lowest data footprint, so the privacy team loves it. But it leaves you wide open to proxies and that ostrich effect. You are flying completely blind.
Okay, so if you want to actually do this right, you probably need to look at mode B. The paper calls this audit only.
I like to call mode B the safe house approach. In this mode, you do collect the sensitive data, the race, the gender, all of it. But, and this is the crucial part, you firewall it completely.
Firewall it from the AI that's actually making the decisions?
Yes. The model that decides if you get the loan never sees that data. It stays blind. However, that sensitive data is kept in a separate, secure audit pipeline.
So you use the data just to grade the teacher, not to teach the class.
That's a great analogy. You run the model's decisions against this secret audit data to generate reports. You can say, okay, the model didn't use gender, but we can see from our audit file that it rejected 20% more women than men. Now you have a problem to solve.
I like that. It feels like a really smart compromise. You get the metrics you need to spot the problem, but you aren't polluting the actual decision logic with that data.
It's often the sweet spot for governance, but sometimes just spotting the problem isn't enough. If you find out your model is using proxies, you need to fix it. And that's where mode C comes in, mitigation and audit.
Mitigation, okay, this sounds more active. Is this where we actually teach the model about race?
Temporarily, yes. I think of this as the training wheels approach, or maybe a vaccine approach. During the training phase of the AI, when it's learning all the patterns, you deliberately show it the protected attributes. You say, hey, model, look at this. This is race. Do not use zip code as a shortcut for this.
So you're explicitly telling it what not to do by showing it the pattern.
You're penalizing the model for relying on proxies. You're sort of vaccinating it against the bias. But, and this is key, once the model is trained and debiased, you strip that sensitive data out. The live model that goes into the real world never sees race, but it has learned a structure that is fair with respect to race.
That sounds incredibly sophisticated. I imagine that's a lot harder technically than just delete column A.
Much harder. And it requires a stronger legal justification under GDPR because you are actively processing that sensitive data to train the system. You have to prove this is necessary for fairness.
Okay, and finally there's mode D, production decisioning.
The nuclear option. This is where the model explicitly uses the protected trait to make the final decision in the real world.
Give me an example where that would ever be okay.
Medicine is the best one. If you're building an AI to diagnose heart disease, biological sex is a crucial medical factor. Symptoms present differently in men and women. You want the model to use that data.
Right, but in hiring?
In hiring or lending, MODI is usually illegal in most jurisdictions. It's essentially affirmative action or positive discrimination hard-coded into the system. You know, if candidate is X, add 5 points. That carries massive legal risk and usually needs specific legislation to allow it.
So the framework basically says, stop pretending you don't have the data. Choose mode B or mode C. Secure the data, lock it in a vault, but use it to check your work and fix your models.
Correct. Don't hide the data. Manage it. Data minimization shouldn't mean evidence destruction. It means using the data only for what is necessary. And the argument here is that ensuring fairness is necessary.
Now, for the listeners who are a bit more technical or just curious about how you actually do this, the paper mentions a toolkit. Because it's one thing to have the data in a vault in mode B, but you still need to understand what the AI is thinking.
Right. You need interpretability. You need to look under the hood. The paper highlights tools like Shape and Lime.
Shape and lime, they sound like a garnish for a cocktail.
They're essential garnishes. Think of Shape as a flashlight. If you have a massive, complex AI model that takes in 500 different variables, SAP shines a light and says, for this specific decision, variable number 42 did 80% of the work.
And if variable number 42 turns out to be marital status, and you're hiring for a software engineer,
big red flag. Why is the model obsessed with marital status? SHAP helps you identify those proxies so you can go in and squash them.
the paper also mentions counterfactuals. I love this concept because it feels very human. It's basically the what-if game.
It is the ultimate stress test for fairness. You take a specific person who was rejected, let's say a black applicant who was denied a loan, and you ask the system, what is the smallest thing this person would have to change to get a yes?
Okay. And hopefully the answer is something reasonable like pay off this one credit card.
Right. If the answer is increase income by $5,000, that's fine. But then you run the same test on a white applicant with a really similar profile. And for them, the answer is increase income by $500.
Oof. So the bar is literally 10 times higher for one group, even if the model looks totally neutral on the surface.
Exactly. The counterfactual reveals that the path to success is steeper for certain groups. That is hard evidence of disparate impact you can take to your boss or to our regulator.
To make this real, the paper wraps up with a case study using the adult income data set. This is a pretty famous data set in the data science world, right?
It is. It's the hello world of fairness research. The goal is to predict if someone earns more than £50,000 a year based on census data.
So they ran an experiment comparing Mode A, the blind approach, against Mode C, the mitigation approach. And what happened?
When they used Mode A, they deleted the gender column and the model had high accuracy. Everyone clapped. But because they couldn't see gender, they missed that the model was heavily penalizing women. It was predicting women would earn less, largely because it was using occupation as a proxy.
So it saw nurse or teacher and automatically downgraded the income prediction compared to traditionally male roles.
Exactly. But then they switched to Mode C. They used the mitigation approach. They told the model during training, we want you to maximize accuracy, but T, you must also equalize the error rates between men and women.
Did it ruin the accuracy? Because that's always the fear, right? That fairness just makes the model stupid.
That is the myth. But the result showed otherwise. They accepted a tiny drop in overall accuracy, fractions of a percentage point, but the fairness metrics skyrocketed. They achieved what's called equalized odds.
So the trade-off is real, but it's negligible. You give up a tiny bit of mathematical perfection to stop discriminating against half the population.
And in a governance context, that is a trade-off almost every board of directors would happily make. We will accept 98% accuracy instead of 98.5% if it means we aren't breaking the law and harming society. But, and this is the kicker, you can only make that choice if you measure it. You can't manage what you don't measure.
That is the big takeaway for me. We have to move past this idea that privacy means deleting everything and never looking back.
It changes the conversation completely. It means that the decision to include or exclude data isn't just a technical switch for a junior engineer to flip. It's a strategic governance decision. It involves legal, it involves ethics, and it involves the C-suite.
And it changes how I look at all these privacy-first claims from big tech companies.
It should. If a company tells you, don't worry, our AI doesn't know your race, you shouldn't feel relieved. You should be skeptical. You should ask, then how do you know it's treating me fairly?
It's the difference between being innocent and just hiding the body.
That is a dark but incredibly accurate way to put it.
So here's the thought I want to leave everyone with today. We often think of privacy and fairness as being on the same team, protecting the user. But in the world of AI, they're often at war. If we want machines that treat us like humans, we might have to be brave enough to let them see who we actually are, at least in the audit room.
Couldn't have said it better myself.
Thanks for diving deep with us. We'll catch you on the next one.